All right, welcome back, everyone. We're gonna get started. Delayed a little bit because the keynote went a little bit long, and we want to let the data track empty out if anybody wanted to come up here. So, all right. So next up we have Ben Alpert and Pamela Fox from Khan Academy. They're going to talk a little bit about interactive learning experiences, interactive learning user interfaces. Perfect. Ben, take it away.
Hi. So yeah, this is creating interactive learning interfaces at Khan Academy, which really means we're just going to tell you about some of the things that Pamela and I build at Khan Academy. And so if you're not familiar, Khan Academy is an online educational website. We have tons of free resources. We have most people know us for the thousands of short, like 10-minute videos we have. Sorry, I'm getting over a cold, but we also have lots of interactive educational exercises, and so like here's the basically our logged in homepage, which is your learning dashboard, where we recommend to you what things you should be working on. Then when you dive into one of these exercises, it looks something like this. And so I'm going to talk about how we build these exercises, and then later Pamela is going to talk about how our interactive computer science environment works. And I just want to mention that most of the things that we're talking about here are all open source. Our main website is not open source, but a bunch of the different components are, including these exercises that I'm going to be talking about. So the theme of my talk today is constraints are liberating. And so to see what I mean by this, I'm going to tell you a story. So when we first had these interactive exercises, the very first version, or I guess the second version, I wasn't around for the first version, but the second version and the oldest thing that we still have in use is called Khan exercises. We were, I guess, really bad at naming things. And so this dates back from 2011, this was this toolkit that we built for randomly generating exercise problems for students to work on. And so we said, why don't we just pick what numbers a problem we'll use, and then we'll be able to randomly generate hundreds of problems. And so we actually built this sort of domain-specific language, which is actually based on HTML. And so it looks something like this, where you have this like vars div, and then you can say like, oh, let this basically says let x be a random number from 1 to 10. Let y number be a random number from 5 to 10. And then you can specify what the problem looks like. You can say, Bob has x apples and Sally has y apples, or something along those lines. And what we did here is actually inside any of these var tags, you can write an arbitrarily complex JavaScript expression. So that means that you can do a lot of really cool things. And so like one thing we did is when you're building an exercise, oftentimes you need to include a diagram of something or some sort of like a plot of a function. And so we built this Graphy library. That's the name of the library as part of Khan exercises, Graphy. And so the way you use it is you do something like this, where you can write this JavaScript code where you're like, oh, I want to initialize a set of axes and a grid, and then I want to draw a function on top of it. And so we built up these primitives, but then we made it so that you can basically do things of arbitrary complexity in the exercises that you're building. And so we actually ended up with some super cool things like here's one exercise that we have, volume with unit cubes, where the content creator, who's also a software developer in this case, built this exercise where it says what is the volume of this shape, and then you can drag it around, and when you're building this, you have the flexibility to do basically whatever you want. And I don't know what your experience is when you let people do whatever they want, but sometimes you run into trouble, and we didn't really enforce any separation of concerns. And so like this is an example of some code that I copied directly from one of our exercises. And so this is from a problem where we say like, oh, plot this inequality, and you need to select whether it's like a shaded line or a solid line or a dashed line, and you can also flip which side. And so we have these like input radio buttons, and then it has like this on-click handler, which like reaches into these like global things and updates it. And so this, it definitely works, and this was good for us in a lot of ways. But really, we found that this is too much power for the content creators, and which at the time were actually mostly just the few software developers who were also working on building the framework, because we found it really hard to find people who were able to do this, because it turns out that math educators and really good software developers don't actually have a huge intersection. We had hoped that they would, but we had trouble finding people who had all the necessary skills. And so what we actually moved to is a system which is more constrained in the things you can build, but then it in turn gives us more flexibility in the changes we can make later. And so this is a system that we built mostly last year, and we're still working on it. It's called Perseus. We have this Greek mythology naming scheme for most of our internal things. And the way Perseus works is, instead of writing code for an exercise and then running it in the browser, we basically have this GUI where you write one of these quiz questions, and when you write the question, it's basically marked down, and you have this live preview on the right, and then we didn't want to force all our questions to be just plain text, and so we created these interactive widgets which you can drop in. And so here's one example. This is the categorizer widget, where we say indicate whether each number is rational or irrational. And we have these 5 numbers, and for each of them you can pick which column it corresponds to. And actually, I really like this example of this particular widget because when we first made this categorizer widget, it didn't actually look like this. I don't have a screenshot handy of what it did look like, but it was basically each of these 5 things would appear on these cards that you can drag around with your mouse, and you drag it into the rational section or the irrational section. And we ended up deciding that this was a simpler interface, and so we were able to change it to this, but without having to go through every single exercise, because each of these widgets is basically self-contained and has very clear inputs and outputs. One issue that we had with this is we said, well, we can build these widgets where each one is pretty self-constrained. We actually have probably 24 widgets now, and each does a specific thing. One is for geometric transformations. One is for, if you want a student to plot a line, then there's a widget that gives them 2 points that they can drag around, and it knows how to check whether the answer is correct and all of that. But one area that we actually wanted to have a fair amount of flexibility is when building diagrams for these pictures. And so, here's an example diagram where this I actually lifted from one of our exercises about the law of cosines. And we want to be able to make diagrams like this where you have some set of lines, and you need to label like sides of a triangle, or maybe it's a plot and you need to label the axes or add tick marks or something along those lines. And it's basically impossible to predict all of the different ways that the content creators might want to add diagrams to their problems. And so we were thinking about like, how are we going to support this use case? And so we had some goals when doing this. We wanted them to be simple to create. We didn't want them to have to learn a whole new drawing tool if they didn't have to. We also one big thing is that we were going for is we want to have a very consistent look and feel of all of the images across our different sections of our site, and we want the same color scheme and the same stroke width on the images and all that sort of thing. And we could have said, just use whatever tool you want, and I'm sure some of them would have used Microsoft Paint, and some people would have used Photoshop, and some people would have drawn it by hand and scanned it in, and you get the diagrams you want, but they wouldn't look very good, and they wouldn't really match each other. And so actually, the system that we ended up using, which I'm a big fan of, is we actually took the Graphy library that I mentioned earlier for our con exercises library and extracted it into this tool which we call Graphy to PNG, where you can write code to generate an image, and then we save this image. And like I said, most of our content creators now are not software developers. They don't really know how to program. And so what we did is we built these templates which they can choose from, where we have most of the different examples that you might want to make for an exercise. But then, so someone who understands how to write code and who knows sort of our style guide and knows how things should look can make one of these templates. And then at the top, we just have these variables which you can fairly easily change. So like here we have the X range and Y range. A little bit lower we have the actual function that's being plotted. But then these bars for this Riemann sum example will change based on what the function is. And so we're talking about this, and initially we were going to just sort of give content creators this text box where they can just like type the JavaScript in, and then that'll run on the student's computer. But I was at least scared that, like, what if somebody writes an infinite loop and it just like hangs the student's browser or something like that? And so actually what we ended up doing is pretty cool, I think, is once you've created a picture that you're happy with, you click this convert to image button. And what this does is it actually fires up a headless browser and then takes a screenshot of the diagram, and it uploads it to S3. And then the content creator can just include that in the problem, and then you don't need to worry about the code executing slowly or something, because it just runs once, and then you have the image file. One other really cool thing we did is when it uploads this image to S3, it actually also saves the JavaScript source right alongside it. So we made it so that when that if you're a content creator and you're looking at an existing exercise we have, you can just look at the source code for an image that's in that exercise and modify it if you want something similar. And so all the things I've talked about so far are examples of how constraining other people helps you. And maybe that makes me sound like some sort of evil overlord or something like that. But my claim is that constraining yourself can be liberating too. And so Perseus is one example of, Perseus, we used React to build it. And I'm not going to talk a ton about React in this talk, although I'm a big React fan and wearing a React shirt. But one place where React actually really helps you out is when you're building your components, they look something like this. And so this is a simplified version of the learning dashboard I showed you on the very first slide, where you just sort of say, here's my mission dashboard component, and when it renders, it should look like this. It should have a div with a class of dashboard root, and then it should have these two other components inside it. And what this does is you don't have tons of code that's just going in and manually manipulating the DOM. And what this allows React to do, and I think most of the modern web frameworks that do this as well, is it allows React to be very intelligent about updating the DOM and only update the parts that have changed. And one easy way to get front-end performance problems is to write to the DOM and then read from the DOM and then write to the DOM and read from the DOM in a tight loop, because then the browser needs to keep relaying out and repainting the page when ideally it wouldn't have to. And so one thing that React does is it's able to structure the DOM operations so it doesn't have any of these loops, and it does this by forcing you, or at least encouraging you, to make these really simple constructs, which then it can optimize behind your back. in a good way. And so, so I like to think of this as falling into the pit of success. This is a Jeff Atwood quote where you want to use tools that make it easy to do the right thing, and that's the path of least resistance, where you want to be able to just sort of do the default thing, go along, and then and end up with something that's good. And so you want to set things up so that you don't need to constantly be trying to improve your code, and so that it to an extent, as much as possible, it just falls out as good structured code. Now, there's one more thing I want to talk about before handing it over to Pamela. And I was thinking, like, how do I tie this into my theme of constraints can be liberating? And really, it's not related to that theme at all. But it is related to these exercises I've been talking about. So it's now unthematic announcement time. And so on our math exercises, we have to often render these math expressions. So like something like, you know, the quadratic formula where it has like square roots and fractions, or like here's an example. This is, I guess, an inverse Fourier transform. I actually just stole it from Wikipedia. We don't teach this yet. But we have to typeset these expressions, and if you've ever written a math paper, you probably know about TeX or LaTeX, which are these standard typesetting systems for doing this sort of thing in print. On the web, there's a library that we were using for a long time and still are for some things, which is called MathJax, which basically implements the TeX math typesetting algorithm in JavaScript and on the web. And we actually found that this the MathJax is slow for a number of reasons, including that it actually does do this pattern of writing to the DOM and reading from the DOM and writing to the DOM and reading from the DOM and causing all these reflows. And so we actually wrote our own version, which is called KTeX. It's like LaTeX, but Khan Academy. So here I actually have a side-by-side GIF of a comparison of loading the same page with KTeX on the left and MathJax on the right. And you can see it's still rendering. OK. I'm going to let it play one more time, just because it's so fun. So yeah, this library is called KTeX. We've been using it in production since last summer, when it actually supported only a few constructs, where we actually would say, you know, if KTeX can render this, then we'll use KTeX to render it. Otherwise, we'll fall back to MathJax. And the appearance of the two frameworks is virtually identical. So you can't really see any visual difference between them. But actually, a fun thing we did is we actually ran an A/B test where only half of our users would get KTeX when it's supported, and then the other half would always see MathJax. And you know, like I just said, they're like basically visually identical. So you wouldn't really expect any difference, except that KTeX is faster. And we actually found that students did like 2 or 3% more problems when presented with the faster KTeX library. And for that, we were still downloading MathJax, which is fairly large over the wire too. And so hopefully we'll be able to avoid doing that at all soon. But today we're releasing this. It's you might have seen it on Hacker News or on John Resig's Twitter account because he tweeted about it like an hour ago. But we're releasing this today, and I'm really excited about it. And now I'm going to turn it over to Pamela, who's going to tell you about the computer science environment.
You guys, if you ever chew on your wires, you can just cover them in duct tape. It totally works. Just FYI. Sometimes I get hungry. It's not going to work with it, no. never know when people decide to message you. All right. OK, cool. So I'm going to talk about the programming environment. So I teach programming on Khan Academy, and we teach JavaScript, and we have talk-throughs, which are like videos, but they're way cooler because it's audio actually synced to the code. And then we have challenges, which actually grade people's JavaScript as they're doing it or assess it and help them practice. And then we have these projects. So we do it all in this live editing environment. So you can see it here, and it's pretty neat. I know, and all my students, they're big fans of Doge. And it's cool because as you edit it, it actually updates on the other side. And there's actually a lot of technology that's going into this editing environment. So I'm going to show it to you using the environment itself. Yay! And so this environment is also open source. So I'm not even checked into their Khan repo right now. This is just off of the open source repo. So as you see, we've got our editing environment here. And the basic setup is actually pretty easy, right? So on the side over here, we've got our ACE editor. So ACE is an open source code editor. I'm sure many of you have used open source code editors. A very popular one is CodeMirror, but doesn't work on iPad. And as we know, there's a lot of people on iPad. ACE does actually kind of work on iPad, even though typing on an iPad is one of the most painful things in the world. But there are people that do it. I know lots of people who say, well, people don't code on iPad. I can show you many people who are learning to code on an iPad, and they are typing in every bit of JavaScript, and it's very impressive. And I just got somebody filed a bug against me 30 minutes ago for iPod Touch. So you never know, right? So you have to be compatible. So on the side, we've got ACE Editor, and here we've got a canvas tag. And we're using Processing.js, which is this library originally designed in Java processing. And it was designed to teach animators and artists how to code because it's all these visual constructs, like make shapes and draw and set colors. And it would give them something like really visual and visceral to play around with programming. And they did all these very impressive projects. And so we thought, well, that's a really fun way to teach JavaScript. Let's do that. And it is actually really, really fun. At least I think that fun stuff are fun. I don't know about you. But it turns out it's actually pretty easy to set up an ACE editor and a canvas output. That's actually something we even have people do when they're interviewing, and that even doesn't take them very long, maybe an hour. So now I want to talk about the things that are actually hard about having this live editing environment. And it may be stuff that you wouldn't think about. How many of you have actually written your own code editing environment? Any? A few? All right. There's a number of them out there. So the first thing is that they are in a browser, and we don't want to crash the browser, OK? And it's actually, if you're live coding, it's pretty easy to crash a browser. Let's see if you can figure out why this might crash the browser. Does anyone see it? Let's see how fast you can read code. What do you think? Yeah, so we have not incremented I or j, which means that if we call this function, it should theoretically crash our browser because we are going to introduce an infinite loop. However, we're not crashing the browser because, and we should get our little error up. What we do is we actually detect infinite loops. And we say, come on, error buddy. You can do it. There we go. So this is Oh No's guy. And everybody has a love-hate relationship with him, also known as Yoko Ono's. And so he said the program is taking too long to run. Perhaps you have a mistake in your code. So it's actually really important to detect infinite loops because as you are writing a loop, it's almost always in a state where it's infinite. Because typically, especially with a while loop, you write your while condition first, and then you write the thing that's going to increment it inside of it. And if you don't have this protection, then you very quickly get into a bad state. And we've broken our infinite loop detection many times, and I can tell you how painful it is because I've learned the many ways that you can write loops in order to not get into the infinite loop stage. So we need a way of detecting this. So it means that we can't run this code directly here. If we run it directly code, it will crash the browser. And I've been in a room with 8-year-olds when we had it broken. They're like, yeah, I crashed Chrome. And they asked their teacher for like a bonus. So we need to make this not happen. So we need to run it somewhere other than the browser. So that's where we use web workers. So we use web workers heavily, and this is one of the examples. So we have a web worker that we actually run the code in first before we'll agree to run it in the actual browser. And it is a little tricky because there's no such, so web workers don't have access to the DOM, so we can't create a canvas. So we can't actually run processing code in a web worker. We have to stub it all out. So we have processing stubs.js, which is, I mean, we took processing, we copy pasted, and we removed some stuff. Very technical. But it's a way of stubbing out processing and making it so that we don't have to access canvas. So most of it is actually empty things. Like anything that has a side effect on the canvas is basically empty, right? The things that are still in there are the more mathematical things, like the p-vector object, where we do actually want it to legitimately calculate things and see how long that would take. So what we do is we create our new worker. And just so you know, everything here is vastly simplified because there's not that much room on here. So we create a new worker, and we send off the code to the worker, and we set a timeout. And we see if the worker comes back, and if it doesn't come back in a certain amount of time, we say, OK, you know what? The worker is not having a good time with this code. We're going to go ahead and assume the browser is also not going to have a good time with this code, and we're going to pop up this message and refuse to process it, right? So this works for infinite loops. And when I say work, like it is still a lot of work, like getting those stubs to work. So there was actually, when I was doing the slides this morning, I found another bug. So I did a push at 7 a.m. to fix it. But it's cool, it's working now. So infinite loops, that's difficult. But it's not just infinite loops we want to prevent. We also just want to prevent slow code. So I did this, there's this whole curriculum around noise and particle simulations and that stuff. And noise is beautiful, right? And at one point I realized I can make this like smoky mirror thing. And I made this mirror on the wall program. And I wanted to actually make the mirror take up the full space. But our noise calculation function is actually kind of intense. And you'll notice it's actually a little bit harder for me to type right now because it's calculating noise at every pixel, right? So if I wanted to make this really big, oh, that was really big. That's definitely not going to work. It's actually going to pop up slightly different message. The program is taking too long to run. Perhaps you could try and make it simpler. So we've done a different sort of detection here. We've detected the fact that, OK, theoretically, you could wait a really long time, and maybe your browser's not going to crash. But it seems highly likely that this is going to be a very bad experience for somebody viewing your program, and we don't want to have very bad experiences. And of course, I've had students like beg to up this limit. But the way we do this is that in that worker that we talked about before, in that processing stubs, what we do is, so we have the actual, some of the code is actually written in the stubs. So the noise function, the full math, we need to have that actually defined in the stubs because we want to know how much work that math takes. And then other things like the drawing, because drawing is kind of intense. You have to draw to the canvas. So we assign a runtime cost to all of the different things in processing. So if we can't find it in the subs file, then we make up a runtime cost. Otherwise, it's like 1 or 0.1. And we add up this whole runtime cost after we call the code. And then we came up with this threshold, and we said if the runtime cost is greater than 16,000, then we're not going to run this code. And sometimes, this might happen in some cases where we legitimately could have run the code, but it's a pretty good threshold to come up with, and it means that for the most part, you end up having good experiences when you're using these programs. So that's something that's important as well. And it'd be nice if we could get this stuff to perform better in the browser so that they could have a smoky mirror that fits the whole way. But that's hard. Browsers, they'll get better. So detecting loops and slow code. Another goal is we want to help the user debug their code. All right, they're using JavaScript. Who here has done JavaScript? It's crazy, right? Yeah. So it's JavaScript. You can get into so many little problems with JavaScript, right? And you're learning to code for the first time. Let's see if we can get an error up. See if you can figure out the errors. I'll give you 1 second. Ready? Go. Haha, you didn't get it, did you? OK. Yeah, be fast. Come on. So oh no, he's up again. This time he's got a line number. And the problem, of course, is what is it? Yeah, I forgot my comma. So that fixes it. Now, if you go through this whole thing, you'll get an entire Argyle pattern. And so we have tons of different errors. So these all come from JS Hint, which is something that hopefully you're running on your code using, maybe in Sublime Linter you're doing it, maybe in your Git hooks you're doing it. You should be running JS Hint at some point in your code base. If any of you are using Sublime Text, you have to get Sublime Linter if you haven't yet. It'll do it in line for you. So we send all of their code through JS Hint. because we want to let them know about these errors. So this is, once again, another worker, because we don't really want to run JS Hint in the browser if we don't have to, because JS Hint is parsing your whole code, finding all this stuff. So we do this other worker, we have the ES5 shim, and we'll send it, and we'll get the errors back, and then we'll pop them up. Now, something interesting with JS Hint, so you know JS Hint was famously forked from JS Lint, which was from Crockford, and the guy who forked it is Anton Kolyov. So he's actually my ex, so I'm very familiar with the way that he, talks. It's great to just use your ex's technology all day. So he's like a dry Eastern European guy. So like the messages are not, maybe the nicest, most friendliest ones. And we're trying to have like a really helpful environment. So we've actually gone through and tried to, make the messages a little more obvious what they mean, because also there's a lot of things. Okay, identifier. What is an identifier? You might know what an identifier is if you've looked at JavaScript ASTs or you've read the spec, but we don't usually talk about identifiers. We talk about variables or property names, right? So I changed that to value or variable name before that comma, because that's something that actually they know. And then we just kind of make it a little more conversational, right? So replace lingo, make it more conversational. So we've done them with a lot of the errors, because that's something we do at scale, is we track the different errors people run into, and when they get confused and say, okay, nobody gets what this means, maybe we can make it better, right? And there's some cases where I've actually taken one JS Hint message and forked it into 2, because we were able to be more specific. You just have to do some regex and be like, oh, okay, all right, now we can give you a more useful thing. But it's hard in JavaScript, because sometimes there's one error you have that, depending on what you're trying to achieve, could be interpreted 10 different ways. So you give them the best error that you can, and eventually you give up and teach Python or something. All right, so that's our JS Hint errors. But those aren't the only sort of errors you might make. All right, so maybe you've misnamed your variables. So perhaps you're like me, and I was born in America and have British parents, so I just get confused. So sometimes I spell color with a U. Not really. Nobody does that. No, but I was using an entire library the other day where every color was written with a U. It was somebody clearly trying to enforce their spelling on the world. That's okay. That's what we get to do as programmers, is just enforce whatever we want to do in our particular library. So here, this is baby hint. So this is coming from our baby hint messages. And one of the things we do is look for spelling, because it's really easy to misspell. And these are, we have people on here who are like 8 years old, 9 years old, right? And I'm sure there's many of you that also, don't feel like you could spell everything. And I don't think we should be penalizing people for that. We should be helping them. Because some people may be just not naturally as good at spelling. Like my brother, he went to Purdue for computer science, and he almost failed computer science because they ran his programs through an automated grader that cared about spelling, and he can't spell anything at all. I think he's dyslexic or something. And so he almost failed computer science because of not being able to spell. Well, it doesn't make sense, because he knows how to program, right? But he didn't have something that would help him with his spelling. So now he sends his code to me, and I comment on his variable names and such. But I think we should have spelling stuff built into more things, and also for comments would be good. But yeah, so we try to help people out by looking at the things they made and saying, okay, it's very close. We calculate the word distance and say the most likely next thing. So baby hint actually checks for a bunch of things. So misspellings, function argument counts. JavaScript, you can send 5 arguments to some functions, but if we know that sending 5 arguments to a processing.js function isn't going to do anything, then we're going to let them know, like, hey, you probably didn't mean to do this, right? So we can actually make JavaScript a little more strict than it is. And then there's a couple other common things we look through for baby hint. But the big things is the misspelling, and that helps a lot. OK, so another thing we want to do is just help the user tinker with the code, especially because this is a real-time visual environment. All right, so one day, my colleague brought in a bunch of really delicious plums, and I ate like 10 of them. And I was so grateful to my colleague that I decided to make a program in his honor. And I spent a lot of time, don't tell me how much time I spent making tributes, but I spent a lot of time making these plums. And the cool thing is that I can just, when I'm positioning these plums, I don't have to figure out what numbers to use. And I'm not very good at figuring out what numbers to use, because I'm still struggling with left versus right and X versus Y, and I always get really confused there. And that it should be okay for you to be a programmer and maybe not be as on top of the spatial grid, right? So instead, I can just use what we call our number scrubber, and I can just move stuff around and change all the values, and maybe I want to go and actually make it an apple instead, and I'll just go and grab a red over here, right? And it's just super useful. And you might think like, oh, I don't need this. But now that I'm so used to this and I go somewhere that doesn't have it, especially with something that's visual, right? Like with Graphy, actually. I was using Graphy the other day, and they don't have it yet. And I know I'm supposed to send a pull request, and I will one day. But once you get used to it, you're just like, oh, I really want to be able to just play with things and see their output. And it's incredibly gratifying. So that's the number scrubber, the hot picker. Those are for colors and numbers. So that's fun. Now, goal number 4, this is actually preventing users from doing things, okay? So I was saying, when you're at scale, you have incredibly smart set of users. One aside, I know we're not supposed to call users users, and I've been trying to come up with alternate names. So sometimes I say students, but then I kind of think that sometimes people are teachers, and I don't want to presume if they're being a student or a teacher in that particular moment. Like, are you making a program that teaches someone? Maybe. So then I say community members, but we don't have a good abbreviation for community members, because it would be like commies or something, which may not be accurate. So when I say users, just pretend I'm saying community members or something nicer than users. So we have so many people in our programming community that they figure out how to do crazy things that we didn't intend them to do. And they will dig so deep into JavaScript and into the code to try and do something that we didn't originally intend. And there are things we don't intend because they're kind of sketchy from a security or a perceived security perspective, okay? So one thing is here. So this was a program that somebody made. And what they've done, so we try to get them not to be able to access the environment variable, the window variable, but sometimes they're able to get to it if they do these different closed over functions. So they were able to access the window.constructor.prototype.open, okay? And they made an alias to it. And they were able to open a window. And that wasn't very good, because then they can do what looks like asking people for passwords. Now, one thing is that we always execute this iframe on a different domain. Okay, so this domain is actually not on the khanacademy.org domain. This is on kasandbox.org. So they can't actually get at user data. But if they ask their user for data, then and if the user gives it and they think, well, this program is hosted on Khan Academy and it's surrounded by this Khan Academy Chrome, so I'll just be happy and give it everything I want. So that's bad. Now, what you'll notice, though, is that it's not working, right? There's no window opening. And this is because we fixed this particular security issue. And a related one is this one. And this one, they, once again, able to get access to the window. And they have to do a lot of crazy things. But they were able to get access to window.location and set it so that if we moused over, it would actually reload this entire output to be this other URL. So that's not good as well, because they could also use that for some sort of phishing. So the way we prevented this is, well, there's a lot of code, but this is some of it. So one thing is to no-op all of the window.constructor.prototype so that those don't actually do anything at all. The other thing is there's this object.freeze and object.seal that you can use in latest JavaScript. You can't use it on Safari because it'll crash and freeze the whole browser. But you can use it on Chrome. So in Safari, we're able to use seal. It doesn't actually work in Firefox either because it'll tell you this error that Windows not configurable. So this basically works in Chrome. Luckily, a lot of people use that. So there's all this stuff you do here. But I was saying Firefox it actually won't work on. So I can go over to Firefox and mouse move. And I'm not online right now, but as you notice, as I mouse moved, it loaded in that URL. Okay? So I wrote a whole document to Firefox about like the 10 different workarounds I tried to be able to prevent them from doing window.location. And I wrote to the whatwig standards list, and I said, it would be really great if you would give us a way of preventing this, this window change. And they, well, they weren't very receptive, so. But it's okay, because I have this other ex, also Eastern European, and he's very aggressive, so I have outsourced the aggression to him, and he's going to be all like, go get him on the standards list. I'm just very like, okay, you don't want it, it's cool, I'll just it's fine. I didn't really need it in the standard anyway, so whatever. And it's related to his thesis, so. And it's actually related to this. So there's an iframe sandboxing, and there's a great tutorial on sandbox iframe. So we tried to solve this with 2 different approaches, because sometimes you need to do that with security. So iframe sandbox, that's an attribute you can add to an iframe. And as soon as you add that attribute, your iframe becomes sandbox. So it's suddenly, your iframe is suddenly unable to do a lot of things. And then what you have to do to let your iframe do more things is you add attributes to that sandbox attribute. So you kind of have to look at the list of things you do want to let it do. So we allow pointer lock, allow same origin, and allow scripts. But we don't allow top navigation, which is being able to change the top, like the actual what's above the iframe, the URL. And we don't allow pop-ups. So that actually would also prevent that window.open, because that's a pop-up. And so the thing I was asking the standards list for Firefox was if they could disable current navigation, and then you'd have to explicitly enable that. So maybe they'll add it one day, hopefully. All right, so here's another thing that people were able to do. So they were able to get an XML request object, and they were able to actually send things to it. So it means that if they were able to get people to type in their password somehow, because you could also just, we have key events. You could listen to the key events. And so you can see, actually, that, so it's erroring right now because I'm not online. But notice, it is actually sending requests to this URL. So that's not good, people being able to just reach out to their servers and send them information. So that's one example of a security thing we were told about. And here's another example. All right, actually, you'll see it, what happens. Oh man, I should get online, because it's a cat picture. All right. So they were able to load a picture in here, which is an adorable cat. So now that they've done that, I actually won't be able to use my slide deck anymore. Like, it's not going to load anything in this thing here, because that code overwrote the entire output iframe. I don't have an output iframe anymore. So this is very bad code right here. And they were able to do this using canvas.outerHTML. So I actually have to reload, and I won't click this time, because I know that that's going to make me unable to do it. So you see, these are 2 security issues that aren't resolved in this live editor. And the reason for that is that the fix for them was a server-side fix using something called content security policy. Have any of you used that yet? A couple? OK, so it's pretty new, but it's also pretty cool. So content security policy is a header, and we set this on our live site, so those things won't actually work there. And what you can do is you can set all these sources that are allowed for particular things. So you can say, like, OK, where can images come from, right? So images can only come from our static server, our main server. And also, we allow data URIs right now. And you can also specifically say that unsafe inline for script is OK, which we do because that's the code we're running. Child source is for the web workers, so we can specifically say where our web workers are coming from. And the really cool thing is this line here, report URI. That is something, so you can actually turn this on in report-only mode. You just change that headers there. You can change it so it's in report-only mode, because it is really scary suddenly adding this policy onto your site and thinking, like, oh, I don't know what's going to happen. So you set it to report-only mode, and you set up this handler, and the handler is going to get all these messages from the server. So we had it out on the server for a couple weeks, and I was monitoring our logs to see what the different things were, to see if there were things that I hadn't, some situations that I hadn't accounted for. And it was really good that I did, because I found there were some things that were handled differently in Firefox versus Chrome, because this is very new. Particularly the fonts were handled differently, and I had to change it. So definitely use that report-only mode if you want to experiment with the content security policy. But it's a fantastic thing. And so what will happen is, like, if you actually wrote that code like on live here, it's not how we use mail. So what you'll see is you'll actually get an error right here. And it'll say, refuse to connect because it violates the following content security policy directive, right? So you'll explicitly see, and that's what you'd get in your logs as well. So really super useful. OK, so those are some of the things that we do. There's a lot more things we do, and I can talk about afterwards whichever things are interesting to you. Does anybody use this mail app, honestly? God. So you know, we have to translate everything. So we've got different translation schemes. So everything is translated so far except for comments. We're going to have to figure out comments soon. But we do that using crowd-in, and then we get all the data in, and it gets crowdsourced, so you could actually contribute to our translation strings. And it's pretty neat. We actually have it all in Hebrew, and it's all flipped. So you have to get everything working in, sorry, L to R, LTR. Or RTL. So you have to get everything working RTL as well. So that's pretty neat. We sync audio to code, and we record all of the talk-throughs in the browser as well. So we do that using Web Worker and the new audio APIs and the ability to actually get access to your microphone. We assess the user code, and we do that by passing it through Esprima, and Esprima parses it, and we use this library called structure.js, and we look for code patterns, and we give them messages. And then we try to be iPad friendly, but honestly, at this point, we're kind of giving up on, not maybe giving up, but we're realizing that syntax typing will always be very difficult, and now we're experimenting with block typing instead. And we've actually got a branch in this repo where instead of moving JavaScript around, you're moving blocks around, but it becomes JavaScript. And so you can take any bit of JavaScript and turn it back into these blocks and vice versa. So that's pretty cool, because if you're on iPad, A, it's blocks. If you're on web, A, it's syntax, right? And so you can just go in between. So yeah, so that's all in that repo. And it's pretty exciting, debugging infinite loops all the time, yay. So yeah, so that's all for me and Ben, and you can talk to us after if you have questions. Thanks.
Thank you, Pamela. Thanks, Pamela. Yeah, we actually have time for a few questions now before lunch. And also, we're going to do the iPad thing again. So again, when it comes around, just like tap the color, you know, good, medium, crap. I think it was pretty good. And then we'll pass those around. So just real quick on that. Any questions for Ben or Pamela? Okay, cool. Well, feel free to come up and chat with them. And then in a few minutes, I think lunch is going to be starting. Lunch will be on the 4th floor. So there's a stairway on the right over there, and then there's also elevators. So enjoy that, and then we'll be back in here at 2 p.m. To kick off the second set of talks. Thanks, everyone.